Okay, now here's where I'm at with this here. You remember in the other videos I was making what do you call it, this regulator? And now I think that's the last video I made. I was making the regulator here. Well, I realize is I don't need voltage regulation for this project. So I took this here voltage regulator apart so I can get the components back off there because I need the transistors, I need the power components off of there. And what I decided to do was go directly with a design like this. This is the torque converter design, and the way it works, as we've seen before, I showed in the other video how this was working. It's about 2 videos back when I showed how this worked. But this will work properly and work really good just coming directly off of the power supply after it's been rectified and filtered off of the bridge rectifier here and come out. I can just use this only, and I can actually use this one circuit. It's going to only need one circuit, this particular circuit right here, and that will cover all the voltages I need. Now let me explain what I'm trying to do here. I want to use 3 different input voltages here. Here's how it is. I have 2 transformers in here. This is the capacitors, the filter capacitor, and I have my bridge rectifier here. Now, what I'm doing here, this is going to be a switch on the lathe itself. It's going to be a switch here. What this does right now is this is the other half of the AC of the secondary of the top transformer here. So when I clip onto here, when I switch onto here like this, I am bringing power out of the full first transformer, which is about 40 volts DC. After it's been rectified, it comes out about 40 volts DC out of here. When I switch over to the second one here now, I pull in the first transformer plus half of the second, which gives me, because these are in series, which gives me 60 volts now, DC voltage out. And then when I switch over to this last one here, I get 80 volts because I have this transformer and this transformer together now working. Both transformers full voltages, so now I've got 40 here and 40 there for the total of 80 volts. Now, what happens is, whichever one I switch into, that voltage is being applied to this circuit here. Now, I built this circuit and I tested it for the 40 volt range, and right here it is, and it worked proper. Whenever I was putting a load on the motor, this light would come on and the motor would, on the lathe, would continue to go nice and strong. When I took the feedback off of there, the motor would conk out. I would actually put a load in the motor and it would actually conk out. But when I put this here back together again on there, the motor did not conk out, which is good, which means it's working. But now after I had all that working for the 40 volt range, I thought, do I need to make a separate one for each of these here voltage ranges here, or can I get the one, just use one circuit only? And here's what I came up with. I designed this circuit right here for the maximum voltage of 82 volts. With 82 volts, I have all the power components in here that I need. And then I decided what I'm going to do is I'm not going to worry about any of the feedback here right now. I'm just going to see if this is going to track properly. When I change the voltages to the circuit, I want to make sure I'm getting proper tracking. And here I'll explain what I mean by that. Okay, for this torque circuit to work properly, it's in this area right here. Whatever the voltage is right here at the motor at that particular time, whichever voltage I use for the supply voltage under this, whatever that voltage is, I need the base of this transistor, which is actually right here. I need this point right here in the voltage divider to be around close to the same voltage as the voltage across the motor here, so that when the motor voltage drops, this transistor can then start conducting. But when the motor voltage is not dropping, this stays out of the circuit for a while, and the feedback is very minimal. But when the voltage drops here, this begins to conduct more. So I wanted to see if this was going to track properly with this. So all I did was, on my bench over here, this is just for a temporary setup, I hooked up this transistor here and this complete voltage divider here in the motor. That's it. I just did just this part right here only. And what I did was then I started applying the voltages to the circuit and to check to make sure that this voltage here is tracking this voltage here. whenever I change this voltage up here. And here's how it works out. Okay, right now I have this on the 40 volt range. By the time I get it to the motor, I want it to be dropped down to 32 volts. So I'll turn this here on, and I'll plug this in now. Okay, I'm plugged in now, and I'm at 32 volts. Okay, that's the voltage across the motor. Now, I have my other multimeter set up here, and I want to check, since the voltage across the motor now is around 32 volts, I want to check the voltage at this point right here and make sure it's tracking properly. That should be pretty close to 32 volts also. So that would be right here. Right there, it would be around right there. And I check up there, and I'm around 32 volts. Alright, so that's tracking there properly at that low voltage. Now, I'm going to check it on the next voltage coming up. Okay, so now I'm going to switch this to, that was the 40 volt range. This is now the 60 volt range. And this should go to about 40 some volts now. Let's see what comes out here. Or 50 some volts. Okay, yeah, 50, because I want about 10 volt drop. Okay, so now I'm at 50 volts across the motor. Again, I'm going to check the voltage here, and I should be close to the same value. So I put it down here again. At that point, I'm getting around 50 some volts. Alright, so that's tracking at this range here. When I touch the positive here, 62 volts. That's a 62 volt range. So I have 50 volts there coming out, so that means I want about 10 volts drop between the motor and the supply voltage at all times. So what it means is the motor is tracking about 10 volts lower than the supply voltage on both ranges. Now we go to the 80 volt range, and this should be around 60 some volts here. So let's try that now. I'll let the capacitor's discharge. Alrighty. Now I'll change this now to the 80 volt range. Now, this should be about 60 volts across the motor now. There it is, 68 volts. Let's check the voltage across the out of the supply. 83, 82 volts. Okay, so we're within a good range there. Now, if I'm at 68 volts across the motor, one more check again. Let's make sure this is tracking here. How close are we tracking here now? So again, we check it here again. 68 volts, 67, so we're within the range of 60 some volts. So what that means is that I can change this voltage up here, switch this voltage in and out, whatever range I want to use, and all this is going to track properly. So since this is going to track properly, I may have to do a little adjustment up here at the lathe. I'll give myself a little trimmer resistor there. This is just for torque, help torque. But what I'll do is I can now just use, all I need to do now is just use the one circuit to take care of all the torque control and motor control for all the voltage rangings that I use. Low, medium, and high voltage would be low, medium, and high speed. And all I need to use is just one circuit will take care of it all. That's what this video was about, was to show that where I'm at on the stages of building this thing now. I got this part built. I've now tested this. I now have this circuit built. I can now actually build this now permanent circuit and then get this thing built and get it working for my lathe now. Okay, thanks for watching. Bye.